All right, so we're continuing to look at volume today, specifically volumes of prisms. So we have Laverne who's making a birthday dessert for her cousin Leslie. She's putting all of her favorite ingredients in there. It's an L-shaped pan that is 9.5 centimeters deep. First, she makes a cookie crust for the bottom. The crust will be 1 centimeter thick so that it's nice and crunchy. Then she's going to add chocolate mousse at 7 centimeters thick, and then finally a 1.5 centimeter layer of whipped cream on the mousse, and then top it all with chocolate sprinkles. So, first question was, what area will the dessert cover on the pan? So this is a view from the top of looking down into the pan. We can divide this up a couple of different ways. I probably would have divided it up this way. And since this is 12, this is going to be 12 also. So showing my work, which some of you like to do someplace in the margin or something else, don't do that. Show your work. The area is going to be, for this part, it's 36 times 12. Plus, for this part, let's see, this is 22 and that's 36. So that leaves what, 14 for this part? So it'd be 14 times 12. I imagine some people did it like it was a square, even though it wasn't. So I have no idea. Let's see, that's 360 and 72 is 272. Is that right at all? I get lots of oomphs today. Yeah. Oh, it was 360. Wow, that was way off. 432. Plus 14 times 12 is 168. And even if you didn't do it this way, there's more than one right way. You should get exactly 600 square centimeters. So is there a question, or y'all were arguing about it?
Yeah, and I still got it right. I got 600. I just divided it differently.
Yeah, you have to divide it up in some way or another.
I divided this.
Did you divide it into 3 rectangles, or did you divide it going across instead of up and down? Yeah. So the other way you could do this is so you did it this way? Yeah, you could do that. The other thing you could do is you could do a whole big rectangle and then subtract out this piece. The nice thing about, because this piece isn't part of it, the nice thing about that is that you don't have to add or subtract to find any of the measurements. Everything's given to you. You would do 36 times 24 minus 22 times 12. Let's see. 36 times 24 is 864. 22 times 12 is 264. Subtract and we get that that's 600 square centimeters. So is there a question? Okay. All right, so Laverne needs to know what quantity of cookies to buy to make the crust layer of the dessert. Does the measurement she needs describe length, area, or volume? Which is it? It's volume. Length is just one dimension, right? I would just say the crust has 3 dimensions. It's got a length, a width, and a thickness. So one cookie will crush into about 5 cubic centimeters of cookie crumbs. So let's go ahead and find the volume. What is the volume of the cookies? Well, the bottom is 600 square centimeters, and how many centimeters deep is that? How many centimeters deep is the crust? 1. So the volume of the cookies is 600 square centimeters times, it's 1 centimeter deep, it's 600 cubic centimeters. So if one cookie will crush into about 5 cubic centimeters, how are we going to figure out how many cookies she needs?
600 divided by 5.
Yeah, so we'll do 600 divided by 5. So it's 120 cookies. All right, now Laverne wants the mousse on top of the crust to be 7 centimeters thick. Use your answer from number 1, part A, to help you figure out how many cubic centimeters of mousse Laverne will need. Well, so the volume of that is going to be equal to the area of the bottom is 600. And that would tell you the volume if it was just 1 centimeter thick, right? But how many centimeters thick is this? 7. So it's going to be 600 square centimeters times 7 centimeters is 4,200 cubic centimeters. Because the area of the base is equal to the number of cubes needed to cover the bottom. And then the 7 centimeters is equal to how many layers deep? The mousse is. So if you think about it that way, the volume is pretty easy. You have the area of the base, which tells you how many cubes it takes to cover the bottom, and then you multiply it by how many layers deep it is, and you get volume. All right, so Laverne has 1,200 cubic centimeters of whipped cream ready to spread on top. Erica looks at Laverne's notes about how much cream she would need and exclaimed, "You have way too much, you're going to overflow the pan." How could Erica know what Laverne has too much whipped cream? She has 1,200 cubic centimeters, right? So we're going to do this the opposite way now. 1,200 cubic centimeters is going to be equal to, how many do I need for 1 layer thick? 600 square centimeters, right? Times, we'll call it h for the height. How would we solve that? Pardon? Times 1.5. How would we solve this for h? I'm not going to minus the 600. I'm not adding it to the h.
Divide.
You're going to divide. When we do that, we get 2 centimeters is the height. And what did we want the height to be? 1.5. Would it actually overflow the pan? Well, how deep is the pan? It's right there at the, yeah, it's 9.5 centimeters deep. That's 1 plus 7 is 8. If I went another 2, that would be 10. It would overflow the pan. All right, so Laverne wants to make sure that her finished dessert will be enough to serve everyone. So let's find the total volume, bless you, of the dessert she's making. So the volume, again, how many cubes does it take to do the bottom? 600 times, how deep is this? How deep is the whole thing? 9.5 centimeters. Let's see. 600 times 9.5 is 5,700 cubic centimeters. If one serving is 285 cubic centimeters, how many people will the dessert serve? What do we need to do to find out how many people we could serve from this?
5,700 divided by 200.
Yeah. Let's see, if we double that, that would be 570. Oh, that goes nicely. It'll serve 20 people.
So if there's only 19, go to the party.
Well, or if there are 20 total.
Nope, someone always takes a little bit too much.
You're very cynical about cake, aren't you? All right. So, what can go wrong on these? Let's take a look at this example. Okay, this is an example of how you can do it incorrectly, and then we'll figure out how to do it correctly. So, here's how Audrey found the volume of this shape. She said, okay, she did 5 times 20. You're like, 5 times 20 is 25.
5 plus.
Or 5 plus 20, excuse me, is 25. So this distance is 25. And this distance is 8. So she multiplied those two together and said it was 200 cubic feet on the bottom, right? Is one layer deep 200 cubic feet at the bottom here? 25 times 8 is 200. And then she said, and the shape is 22 feet high. So she multiplied that times the 200 and got 4,400 cubic feet.
It's only that big, a little bit, and there's that part.
Try saying that as a sentence in
There's
English.
Only, the 22 is only like a part, and then the other part there's like another part that's shorter.
Yeah, the two parts, there aren't 22 layers that have 200 little cubes in them, are there? Okay, so yeah, she assumed that the height of the whole shape was 22 feet. And it's not. Okay, now let's see if we can find the volume of the actual shape. There are a couple of ways you can do that. I'm going to do it the shortest way possible. Okay, or at least what I think is the shortest way possible. Instead of using what's on bottom, because when I go up, the layers become different when I get high enough up, right? What if I used the side that is facing me and I did layers that way from front to back? Would all the layers be exactly the same then? Yes? Okay, so if all the layers are exactly the same, I just need to find the area of the front and then multiply it by how many layers I would have going back. So for that, I'm going to do the same sort of thing we did on this other one. I'm going to split this up. The area for that is going to be 22 times 8 for this part, plus this will be 20 times 16. That's 176 plus 320 is 496. And then from the front to the back, how many layers would she have of that? There's going to be 8 layers of that. So it'd be 496 times 8. I'm not going to try to do that one in my head. It's 3,968 cubic feet. Okay. All right. So you've got over 15 minutes still left in class. Please get started on your assignment.